is the atmospheric pressure. Atmospheric pressure. You know that Earth is like this. So there is a envelope of air all around Earth. There is an envelope of air all around Earth. Is it clear? So this, which can be seen here in light blue color, this envelope of air is called the atmosphere. This atmosphere is exerting a pressure on the Earth. This atmosphere is exerting the pressure on the Earth. Each and everything on the Earth is feeling this pressure. Okay? So this pressure is being exerted by the atmosphere. And why this atmosphere is exerting this pressure? You know that Earth has a huge mass. In the same way, the air particles also have mass. Air particles have mass. So whenever a body is having mass, obviously it has the weight also. Whenever a body is having the mass, obviously it will have weight. So due to that weight of those particles, that force of attraction of Earth is attracting those particles towards itself, due to which that pressure is being generated. So that's why this pressure is called atmospheric pressure. So atmospheric pressure also called the barometric pressure. So atmospheric pressure, here you can see the definition of the atmospheric pressure, the barometric pressure. Force per unit area exerted by an atmospheric column, that is the entire body of air above the specified area. Whatever the area is on that specified area, whatever the pressure is being exerted, that pressure is called atmospheric pressure. Okay? I told you that the Earth atmosphere is bearing down on all of us with a pressure at sea level. We are talking about the pressure at sea level now. Okay? At sea level, this pressure equivalent to around 10 tons of the weight per square meter. It means on a 1 square meter, 1 meter length, 1 meter breadth, on that area, how much pressure is being exerted? That is equal to the 10 tons of, almost, not exactly, almost 10 tons of the weight per square meter. So simply standing upright, if you are standing like this, so standing upright, so it means that carrying the weight of a small car, if you are standing upright, it means you are carrying the weight of the small car. So why you are not feeling that weight? Can you tell me? The reason we cannot feel it, that the air within our bodies, that why we are not feeling that tons of weight of the of air on us. The reason we cannot feel it is that air within our bodies, that is our lungs and stomach, for example, is exerting the same pressure outward. So there is no pressure difference and no need for us to exert any effort. Yes, atmospheric pressure decreases when you are going higher and higher. If you are at the sea level, then it is largest. Here you can see that the density of the particles of air is more. When you are going on a higher altitude, then its density is decreasing. Here there are less particles can be seen. So from this figure, I just want to explain you that here this is lesser pressure, but when you are moving up to the mountains, then the pressure is decreasing. So remember this, whenever you are going higher and higher, the pressure is decreasing. Okay, with the help of an experiment, we can see that whether atmosphere is exerting pressure or not. Okay, with this experiment, you know that there is an experiment, can crushing experiment. With that experiment, we can understand that atmosphere can exert pressure. Before telling this experiment, let me explain you the theory of this. Just a minute. Before telling this, let me tell you that how we are going to conduct this experiment to prove that atmosphere is exerting pressure. Because here we are not understanding now, because you can see that we are not feeling any atmospheric pressure. So what is the proof? How we are going to prove that atmosphere is exerting pressure? Now, for this understanding that atmosphere is exerting pressure, we can conduct an experiment. In this experiment, what we are going to do? We are going to have a can. You know that a tin can. You will have to take a tin can which has a small opening at here. Okay. Now this tin can is having, what is inside this? Air. There is air inside this tin can. It's opening from here, it is open. There's a small opening here. Okay. What we are going to do? We are going to have some water in it. A little water. You have to pour some water in it. Now you have air and water. These two things are here in the can. Next, what you are going to observe, that this can is maintaining its shape. This can is maintaining its shape. Why it is maintaining its shape? Actually, air is exerting pressure from outside, and air is also exerting the same pressure from inside. The outside pressure and inside pressure are equal to each other. When these two pressures are equal to each other, so this can is maintaining its shape. Is that clear? So both the pressures on all the walls of this container are equal. That's why this container is able to maintain its shape. Clear? Now I told you that you have poured some water in it. After pouring some water in it, you will have to start a burner under it to boil that water. Okay? We have lit a burner or anything, a fire, we have lit the fire under it. Now the water will start boiling. When the water will start boiling, what will you observe? You will observe that steam will be coming out of it. You will observe that steam is coming out of it. It means when this tin is full of steam, then what do you think? What is inside this tin? Now, when the water is boiling and the steam is coming out, what is inside this tin? So now here inside this can there is only steam and water. Okay, so you know that steam is the gaseous form of water. Okay, now it's clear that this tin is containing two things. One is the steam, which is the vapor form of water or the gaseous form of water, and other is water. Okay, now what we are going to do? We have to stop boiling it. Just put off the flame, and now after putting off the flame, you will have to tightly close this opening. You will have to close this opening, and you will have to make sure that it must be airtight. You will have to make sure that it must be airtight. When it will become airtight, now in this container, no air can enter in this. Okay? Now when it is airtight, no air can enter in it. Now you can see that atmospheric pressure is there, which is from the outside. From inside, which thing is exerting pressure? Steam. The steam is still exerting a pressure. That's why the shape of the tin is maintained. Because there is steam in it for some time. That steam till it is not getting colder and colder. So steam is exerting a pressure. So the moment you are closing it, the moment you have capped it tightly, then you will have to pour cold water on it. You will have to pour cold water on it. As a result, what will happen? What will happen basically? When you are pouring the cold water on it, the steam inside will condense. The steam inside it will condense, and as a result, the steam will become water, but there is an atmospheric pressure from outside. The inside pressure has decreased due to the condensation of steam, because steam has condensed. Steam has condensed, so inside pressure has decreased, but still the atmosphere is exerting the pressure. So that is why the shape of this container will crumble. This tin will crumble. Okay. Now let us see that how it is going on. Okay. Now here you can see that there is a big drum type can. So he is boiling the water in it. There are burners under it which are boiling the water. Okay. The water is being boiled, and you can see that the steam is coming out of it. Steam is coming out of it. In between that, steam has expelled all the air from inside. Okay. Now this tin is containing only steam and water. After some time, what he is going to do? He is going to stop heating it. Now he is going to tight it. Okay. Now he is going to airtight it. He is closing the opening. and they are removing the burners under this can. Now next, what is going on? You will have to observe. Now next, he is going to throw cold water on it through pipe. He is going to pour cold water on it. You can observe it. Now you will have to see it very carefully that what is happening, as I told you, that when you are pouring cold water on it, the steam inside will condense. The steam inside it will condense, and you will
stand your ground, friend.
From all the side, he is throwing the water so that from all side it must, you can see that the can has, this drum has crumbled like this. Okay.